Calculations using density. Recall that our definition of rate is that a rate is a comparison of two quantities that have different units. It is often expressed like a fraction, one of the numbers being compared over the other, like rise over run. We will use a lot of rates and ratios in chemistry. The thing we call density is actually the relationship between an object's mass and its volume. We did a lab to figure that out. We have seen how we can use this relationship in the form of a graph of mass versus volume to obtain the volume of an object from its mass and vice versa. We can do the same thing a different way using the density in a calculation. We can use the numeric value of the density just as well as we can use a graph to relate mass to volume. The procedure is actually the same. We begin with the given value, which is either a mass or a volume. Then we apply the density, the relationship between them, to get the volume that goes with a mass or vice versa. The idea of a given value or given is important. We always start with the given and then use the relationship to get to the thing we want. Use the relationship in this case means multiply. We have talked about how the slope of a graph is a rate of change or rate, how rapidly one quantity changes when the related quantity is varied. Multiplying by a rate converts from one value to the related value. It is equivalent to reading from a graph. We will use this strategy in other contexts. Let's do an example. So, in solving problems, the first thing we have to do is read the problem. A cube of aluminum has a volume of 8.00 centimeters cubed. What is the mass of this amount of aluminum? Now, with any word problem, it's good strategy to make a diagram or map we can look back at to see what we're doing so we don't have to reread. We are given a quantity in centimeters cubed, which is volume, and we're asked for mass. Units of mass are going to be grams, so we're going to write centimeters cubed to grams. We're given centimeters cubed, we want grams. This is going to help us now. So we look at what we wrote. To convert, we need a relationship between these two things, centimeters cubed and grams, and that relationship is the density of aluminum, because the problem's about aluminum. Now, we can look it up. The given is important. Forgot about that. The density of aluminum, we can look it up. 2.7, it's actually 2.702 grams per centimeter cube. We can write this as a rate two different ways. We can write 2.701 grams in 1 centimeter cubed, or we can write 1 centimeter cubed has a mass of 2.701 grams, should really be 2.702. Now, we are going to use one of these rates here, and the one we want is going to be the one that has our target unit on top. Our target unit is grams from our map up above, so we are going to circle the one that has grams on top. Now, we're going to start with our given, circled, 8.00 centimeters cubed, and now we are going to multiply by the rate that we identified that has our target unit on top, 2.701 grams in every centimeter cubed. Now we're going to go back to analyzing units. We see we have centimeters cubed in the numerator and denominator, so we're going to cross that out. The only unit that is left is grams in the numerator, so that's going to be the unit of our answer. And we multiply, we evaluate the numeric portion, which means multiply all the numerators, divide all the denominators. We get 8.00 times 2.701, and that gives us 21.6 grams. All right, let's review what we just did. We read the problem and identified the given. We drew a diagram or map of the problem. We found the relationship, that is the density, that relates the quantity we were given in centimeters cubed to the quantity we wanted in grams. And we often have to go look outside the problem for the relationship. We wrote this relationship as two possible rates and chose the one that would give us what we needed, the one with a target unit on top. We wrote the given first, multiplied by the correct rate, analyzed units and the numerical answer, and we were done. Let's see another example. All right, read the problem. What is the volume of 50.0 grams of ethanol? All right, let's make a map. We are given grams, that's mass. We're asked for volume. That means we're going to get want to get a quantity in centimeters cubed. So let's write grams to, milliliters, because it's liquid. Ethanol is a liquid. Grams to milliliters. All right, so what is the given? The given is in the problem 50.0 grams of ethanol. All right, so now we need to look up a relationship between grams and milliliters, and that's going to be the density. The density relates the mass and the volume. So we can look it up at 0.789 grams per milliliter, and we can write this as a rate two ways. We can write 0.789 grams in every milliliter, or 1 milliliter has a mass of 0.789 grams. Let's look back at our map. Our target unit is milliliters, so we're going to choose the rate that has milliliters on top. Now we're going to start by writing our given, 50.0 grams. We're going to multiply by the rate we identified that has our target unit on top. Now we're going to look at the units. We have grams in both the numerator and denominator, so we're going to analyze the units, get rid of grams. Milliliters are the only units left. So now we know milliliters will be the units of the answer, and we analyze the numeric part of the problem. Multiply every numerator, divide by every denominator. That means we have 50 times 1 divided by 0.789, and that's going to give us 63.4 milliliters. Okay, quick review. We have previously used the relationship between mass and volume in the form of a graph to go from the mass of an object to its volume and vice versa. Here, we use multiplication by the rate, which is the slope, to do the same thing. This way, we do not need a graph, and we usually get more precise answers, more significant figures without needing to estimate anything. To be able to reliably work density problems, practice this routine until each step flows easily into the next.